Hello students, we are studying IPsec, that is Internet Protocol Security. In this video, we will be studying Security Association. If you remember, in case of Authentication Header and ESP both, there is a field called Security Association in the header. So we'll see what is Security Association. So Security Association is actually a very important aspect of IPsec. IPsec requires a logical relationship, which is called security association between the two hosts. So this here we will first discuss about the idea of what is security association, and then we'll see how we can use it in IPsec. So security association is actually a contract between the two parties. It creates a secure channel between them. Let us assume that Alice needs to unidirectionally communicate with Bob. So if Alice and Bob are interested only in confidentiality aspect of security, then they can get a shared secret key between themselves. So here we can see that there are two security associations between Alice and Bob. One is a outbound security association, and the other one is an inbound security association. And each of them stores the value of the key in a variable and the name of the encryption decryption algorithm in the another variable. So here you can see the example of simple security association. So the two entities, Alice and Bob. So this is an outbound security association of Alice, which will hold the value of algorithm to be used and the key to be used. And this is the inbound security association. So outbound security association is to be used for sending the messages, which will hold the information about the algorithm to be used and what would be the key while sending the message. And inbound security association is applied when some message is received. So here Alice uses the algorithm and the key to encrypt the message to Bob, and Bob uses the algorithm mentioned in inbound security association and the key when he needs to decrypt the message which is received from Alice. The security association can be more involved if two parties need message integrity and authentication, and each association needs other data such as algorithm for message integrity, the key, and the other parameter. So it can be much more complex if the parties need to use the specific algorithm and the specific parameters for different protocols such as AH or ESP. Now, the another important concept which you should understand here is the security association database. So, where all these security associations are stored. The security associations can be very complex, and this is particularly true if Alice wants to send message to many people and Bob need to receive the message from many people. So, in addition, each side needs to have both inbound and outbound security association to allow the bidirectional communication. So here we can see that we need a set of security associations that can be collected into a database, which is called as a security association database. So this database can be thought of as two-dimensional table, with each row is defining a single security association. So your security association database will look like this. Each row is responsible for defining a single security association, and normally there are two security association database. One is an inbound security association database and another one is the outbound security association database. So here we have SPI, which is a security parameter index. Then we have a destination address, and P is indicating a protocol to be used. Okay. So when a host, and these are the different parameters. So when a host need to send a packet that must carry an IPsec header, the host need to find out the corresponding entry in the outbound security association database to find the information for applying security to the packet. So whenever the host is sending the message, he has to use the outbound security association database. Okay. And similarly, when the host receives the packet that is carrying IPsec header, then the host need to find the corresponding entry in the inbound security association database to find the information for checking the security of the packet. So this searching must be specific in the sense that the receiving host need to be sure that the correct information is used for processing the packet. And each entry in the inbound security association database is selected using a triple index, which is security parameter index, SPI, the destination address, and a protocol to be used. So the protocol can be AH, ESP, and mode can be IPsec mode flag, whether it is set or not. Then it can be having a sequence number, overflow flag, anti-replay window, what is the lifetime, and then the path maximum transfer unit. So what is it? SPI, that is security parameter index. The security parameter index, as we have seen earlier also, it is a 32-bit number that defines the security association at the destination. As we'll see later on in the further video, that SPI, that is security parameter index, is determined using the security association negotiation. And the same security parameter index is included in all IPsec packets which belong to the same inbound security association. Then the destination address, the second index in the destination address index is the destination address of the host. So we need to remember here that the host in the internet normally has one unicast destination address, but it may have several multicast addresses. So IPsec require that security associations be unique for each destination address. And the protocol field is like IPsec has two different protocol. We have seen AH and ESP, and to separate the parameters and information used for each protocol, IPsec require that destination define a different security association for each protocol. Now, these are the typical security association parameters. So, first one is the sequence number counter, as we have already discussed in the earlier video also, that this is a 32-bit value that is used to generate the sequence number for AH or ESP. Then sequence number overflow is the flag that defines the stations option in the event of sequence number overflow. Anti-replay window will detect the inbound replayed AH or ESP packets. AH information will contain the information of AH protocol like authentication algorithm, what are the key value, what is the lifetime of the key, and the other related parameters of AH. ESP will again hold a related parameter to ESP protocol, at which encryption authentication algorithm is to be used. What are the keys, what are the lifetime, what is the initialization vector for using the hash algorithms. Then security association lifetime defines the lifetime for security association. IPsec mode, which IPsec mode is used, transport or tunnel, that is set. Then path maximum transportation unit is used whenever the packets or the datagrams are fragmented. So these are the different security association parameters.